All right, so we're moving on to multiplication now of integers. So you'll have your name on your paper. We've done a little bit with the number line, and now we're getting ready to move on to how to model multiplication of integers with these two color counters or the circles, however you want to refer to them as. So we're going to start with 3 times 4. Now remember the parentheses around the 4, those do mean multiplication. So it's different than where I said the parentheses before were separating a negative sign from the operation. There's no negative sign, there's no other operation going on other than multiplication. So the parentheses can show multiplication. What this means is the 3 times 4, as you see here, means 3 groups of 4. So the first number tells you how many groups you have. The second number tells you how many are in each group. So we're going to start by forming our groups. We want 3 groups of 4. So this is a positive 4. We're going to use the positive circles. You would just draw on your paper 3 groups made up of 4 circles each that have the positive sign written inside of them. You could also see some questions where instead of the positive sign written inside of them, they might have a key over to the side where a certain color represents positive or negative, just like we were using the reds for the negative and the whites for the positive. So I have 3 groups of 4. At this point, I can just count up my total number of circles or chips or counters or whatever you want to call them, and that would give me a total of 12. And obviously you guys know that 3 times 4 is 12, but this is how you could model it. You have the 3 separate groups, each that had 4 within them. So for the next question, there is a negative sign within the parentheses, but there is not a separate operation sign that the parentheses are separating the negative sign from. So in fact, the parentheses mean multiplication again. So parentheses are another way of showing multiplication. So I have 3 groups of -2 in this instance. So I'm going to drag my negative circles over. So 3 groups of -2. So that means I want 2 negatives in a group, because that would represent -2, and I want 3 groups that have -2 in them. And it doesn't matter how you line them up. If you want to have some of them going vertically, some going horizontally, it doesn't matter. You just have 3 groups of -2 rather. And then you would count them up, and I would have a total of 6 circles, but they all have negative signs in them, so that would represent -6. So you would write that in as well for your answer. Okay, so now as we get into some of these problems, these ones you can use the models to help you answer them, but I can't see how they would ask you a question on your actual SOL about modeling this, because would be pretty much impossible to model in and of itself the way it's written. Okay, so what this is saying, the -4, and I'm multiplying it by 2, that means -4 groups of 2. Well, that doesn't really make sense. How can I have -4 groups? So there's a couple different ways that you could model this. The first way is what's on the screen right now, where you could use the commutative property of multiplication. So the commutative property of multiplication says that I could switch my order around, the order that I multiply, so switching that -4 with the 2, and then saying, well, that's the same as 2 times -4, and then modeling the 2 times the -4. Okay, but if you model 2 times -4, it's not technically modeling -4 groups of 2. It's not technically modeling -4 times 2, but it will give you the same answer. So if you're trying to solve it, you can use the commutative property, switch it around, and model 2 groups of -4, but it would not look the same because you can't model negative groups, okay? So I will do that first, and then I'll show you the other way. So the first way that you could do this is, and I'm going to kind of move this out of the way a little bit, or try to, okay, is I could go ahead and, let me delete this so it's out of the way. I could go ahead and model that one that it tells me to model, which I'm going to get rid of all that writing, and I'm going to like draw a line down the middle of my screen so that I can kind of separate like one way versus the other. So if I model 2 groups of -4, that would mean I would take those negative circles or negative chips or whatever it is you want to call them. And so I would want -4 in a group. So 4 of them would make one grouping. And it doesn't matter if you put them in rows or if you want to put them in kind of little squares like this, as long as it's 2 groupings of -4. So if I do it this way, using the commutative property, I would have 2 groups of -4, which when I count them up, I would have a total of 8 negatives, or -8 that way. Okay. Now the other way is to think about that negative sign that's in front of the 4 at the beginning there, and that meaning the opposite of. So the opposite of 4 groups of 2. Okay, so if I do it this way, I would start out with actually doing 4 groups of 2. So here's a group of 2, here's a group of 2, here's a group of 2, and here's a group of 2. When I say the opposite of it, it's like I'm flipping over my little chips, my circles, to the other side, because the opposite, so right here, what's modeled is a +8, okay? So right now, this right here is a +8, but when I take the opposite of 4 groups of 2, that's like going ahead and flipping those chips over to the other side that's negative, right? Taking the opposite of that, the opposite of a +8, of course, would also be a -8. So if I were to flip those chips over, those circles over, to get the opposite value of what was on the front side, that would be helping me kind of indicate I'm taking the opposite of 4 groups of 2, or the opposite of a +8 would be a -8. So it's, and again, what I modeled on the left technically is 4 groups of -2 once I have flipped them over. So again, you would get the same answer. Neither of these examples are technically modeling -4 times 2, because you can't. But you would get the same answer if you were trying to solve the math problem. So when it comes to modeling, they would not be able to ask you a question about what model matches us, because nothing will match it. What they might say is what model is equivalent to that, because what that would mean is you would get the same answer as the problem that's given. So which model would also give me a -8, like I would get if I did -4 times 2. So couple different ways to look at this here. Either way that you do it, you would get -8 as your answer. All right, so the next question is like the one we just finished. I have -3 times 4. Again, those parentheses mean multiplication. So this is the same as saying -3 groups of 4, which also doesn't make sense. How do I have negative groups? So just like this last problem, I will move the note over here about modeling 4 times -3. So you can use a commutative property again to model what it would be like if you switch those numbers around, right? Commutative property. I need to get my pen back. The commutative property, again, says that I could switch the order and it would mean the same thing. So I can instead model 4 times -3 and I will get my same answer. So that's where I'm going to start. I'm going to move these out of the way here, or get rid of them, so that I have space on the right-hand side of the screen. And we're going to start by modeling that like we did last time as well. So I'm going to split my screen in half here, down the middle, and I'm going to start with 4 groups of -3. So I will use those negative chips in order to, or circles, whatever you want to call them. I want 3 in a group, and I want 4 groups of -3. So I've got 2 groups of -3, and if you want to put them in rows, so if you feel like that gives you more space, you can, as long as they're kind of clumped together. I'm kind of doing them in an upside down triangle format. Okay, so I have 4 groups of -3. If I were to count those up, I would have a total of 12 negative circles, which would give me an answer then of -12. Oops, I lost one of my I'll have to write it in here. I lost one of my circles, or maybe I forgot to drag it down. So let me drag the circle down. There we go. Now, if I were to do the other method where I said that that negative sign in front of the 3 really means the opposite of 3 groups of 4, then I would start by dragging 3 groups of 4. So 4 in a grouping this time, and I'm going to go in rows this time so I have a little more space, I feel like. So I'll do kind of 3 rows here, 3 groups of positive 4. And then that would give me, once I get them here, that would end up giving me a positive 12. And you're drawing your circles on your paper so that you can follow along. So when I have my 3 groups of a positive 4, okay, that would give me a total of a positive 12. And we said we're looking at that negative sign as meaning opposite of. Okay, opposite of 3 groups of 4. So then if you take the opposite of 12, it's again just like flipping over those 12 positives to the other side, which is the negative side of those circles, of those little counters or chips. And I would end up then, the opposite of a positive 12 would be a negative 12. So as I drag these over to kind of represent flipping them over to the opposite side, I'm going to throw in my negative sign in a second for my 12. Because the opposite of a positive 12 would then be a negative 12, which is going to be my answer that I'm going to write up top. So negative 3 times 4 is a negative 12. All right, so in this last example, I have negative 5 times a negative 2. So that would mean negative 5 groups of negative 2, which we know does not make sense. I can't have negative groups. But even if I were to use the commutative property and switch negative 5 times 2 to a, switch it around and get negative 2 times negative 5, I still would end up with having to form negative groups. Because if I did negative 2 times negative 5, that would mean negative 2 groups of negative 5. So either way, I'm stuck with negative groups. So this is where I absolutely have to use the idea that the negative out in front means the opposite of. So what I will have to do is model 5 groups of negative 2 and then switch them around so it's the opposite of it. So I would start with, so I'd have groups of negative 2, so 5 groups of negative 2. I will go vertically so I can fit them. 2 groups, 3 groups of negative 2, 4 groups of negative 2, 5 groups of negative 2. So right now, as is, if I have 5 groups of negative 2, that would end up being a negative 10. But I want the opposite of 5 groups of negative 2, which means I would have to flip my little counters over or turn them positive. So then once I turn them positive, instead of having a total of negative 10, these are becoming positive, and I'm going to end up with a positive 10. So on your paper, you probably just have to take that negative sign and turn it into a plus sign, like draw a line through the middle to turn it into a plus sign. And same thing here, I'm going to end up turning that negative sign into a plus sign when I take the opposite of it. So negative 5 times negative 2 is going to be a positive